All right, let's see here, everything makes sense. Yeah, we should be live. Good. Be right back, hang on. All right. Let's see what we are going to do. So today we are going to be playing around with adding some encryption. So we have here previously made a Diffie-Hellman key exchange. So what that actually means is effectively a process where we send some content over the wire to establish what's known as a shared secret. So this process is very, I'm no expert. Effectively, it relies on the difficulty of some mathematics, namely exponentiation and modulo, to effectively guess parameters in, even though we exchange parameters ostensibly in public, they are exchanged in clear text, so plain text, that is. Meaning if someone was listening to our connection, effectively, right, as they can, this is not an impossibility, they would see numbers being exchanged. And these numbers, ordinarily, if we were just sending information over the wire and so on, this information could, of course, make it so that any kind of secret value we try to establish would be seen over the wire by someone monitoring, of course, our communication. But with Diffie-Hellman key exchange, the values that we do exchange are not enough to actually recreate the shared secret. And so you can see here that, first of all, let's look at the result, right? We have a client here on the right side, right? And a server on the left side. The client and the server are exchanging public keys and two predetermined values, basically, that the client comes up with in this particular case. And these values are then used to establish a shared secret. And we can see both the client and the server are reaching this result here that is the same in both cases, right? So for us here, we can see 188511067, etc., 188511067, and so on. So we have 28836 at the end, and so on. So both of them end up with the same view of what the secret is, right? That's basically now a value that the client and the server both have, but an observer from the outside cannot have this. And this relies on effectively, there you go. This relies on this process here, which is Diffie-Hellman key exchange. So if I zoom in here a little bit, maybe, these are my notes on Diffie-Hellman. I take notes on all of these things. These notes, by the way, are available if you are a $4 or more patron. So on my Patreon, this is one of the incentives, basically getting access to my notes on some of these things. And that research and everything is what I'm basing all of these things on, right? So we have notes on, well, many things, general security notes, notes on hashing, different algorithms and their block sizes, digest sizes, and so on, symmetric encryption, asymmetric encryption, etc. Lots of things in reality, right? You can see here on the left, there's quite a few things. Not all of it is security related, of course. I have notes on many things in the end. OpenGL, I wouldn't necessarily say these notes are super extensive, but they are enough to give some intuition about what OpenGL is and so on, how it works under the kind of what is going on and so on. An intuition for what perhaps you should expect from OpenGL, for example. Anyway, that's not what we're here to discuss. Diffie-Hellman is this key exchange protocol for basically arriving at a shared secret between two parties, but not having a outside observer being able to recreate that secret, right? So it starts with a prime P and a generator G. Then each side chooses a private key on both sides, right? This is private, meaning we're not going to share this one. We calculate a public key from our private key and P and G. So we have G to the power of our private key, right? These are numbers, obviously. And then modulo P, which is our prime, right? And P here is a massively, it's a large number, right? It's on the order of 2,000 to 7,000 bits in size, right? And it has to be prime. So this takes a while. We saw this yesterday. It took for a 3072 bits large number, it took us about 20 or so seconds if we have a primality test of 64 tries and so on. So this is quite the calculation. It's fairly expensive, fairly slow, and so on. Also requires allocation. It's very tedious, very, but this is what we want it for, right? We want this P number, this prime, for this process. So it's important, of course, that we do this, right? Once we have our public key, we send this public key to the other side, right? When they have this, they can actually use that public key to the power of their own private key, modulo P again here, right? And so what we did yesterday was we effectively implemented this, and that's how we arrived at this, right? Having a shared secret that we both calculate on a client and a server side, right? So what we're trying to do today is exploring what can we do now, right? Because now we have a shared secret. What is that secret good for? Well, what we're going to try is we're going to try to use ChaCha20, which is a encryption algorithm, a symmetric algorithm. So a symmetric algorithm is characterized by having, let's see here if we can. Symmetric encryption works by having the same key encrypt and decrypt, and so on. And it requires significantly less bits in order to do something. We have a shared secret. We have a number that both of these parties possess. What we're going to do is we're going to hash that number with SHA-256 on both sides. That is our key. We're going to use that with ChaCha20, right? And this is going to be our, this is going to be our key for this. And so that's what we're going to try to do. We're going to explore a little bit the APIs and so on. Like we did yesterday, we looked at what is the API for all of this stuff, right? How does it work? Because of course, this is not normal. Let's say it's not normal programming, right? Just to show a little bit of that, we are using big ints, right? They have their own module, a module that is very peculiar, you could say. Let's go to random here. So internal random prime here is a function that exists in this module, and this is obviously what we're using. We ended up lowering the bit size here to 2048 just for, honestly, dev purposes and so on, right? In reality, we probably would want to bump this up a little bit. But if we look at the documentation here for internal random prime, which by the way, this is not an internal function, it's completely callable from outside. I don't know what to say here, that, it is somehow callable from the outside. And we can see here that it is quite a module, right? It is fairly interesting. It has this note here. This is possibly the mother of all prime generation functions, and so on. So we are in a part of Odin here that is a little bit special, right? We wouldn't normally end up here necessarily. There's something a little bit, you know, interesting about some of these things, right? I want to mention also an alternative kind of way we could go about using this shared secret, right? So there's an interesting kind of example here of it, right? So you see this rand parameter here, right? When we create a rand instance, right? This is a random number generator, right? We could effectively use our shared secret or part of it, for example, as a seed, right? We could even hash something and then use that as a seed, right? And seeding, when it comes to random number generators, is effectively a way of saying, here is the random sequence I want you to have, right? This is commonly used nowadays, for example, in games. You can actually play on the same seed as someone, which means you're going to have the same randomness as them if the game is architected like this, right? So what we can do is we can effectively say, we both know the seed. No one else in history can know the seed. It's impossible, right? So we can get the same randomness, which means every time we ask, if we ask in the same order and so on for random numbers, we will actually get the same result. So this would also be a way we could use this value, right? We could essentially seed a random number generator and we use it a certain way. For example, if every message uses randomness back and forth, we would effectively move in lockstep with each other, both sides of this equation, right? So that could also be a way we could use this. We are just going to hash this and see what we can do with it. That's basically it, right? So with that in mind, we're going to import some modules. I want to establish a few I'm going to check a few things here. This should be in SHA-2. No, hash SHA-2 actually, if I remember correctly. No, hang on, crypto. Yeah, crypto SHA-2. I can never remember, honestly. And I think this also implies that we should have cha-cha. Yeah, cha-cha 20. Now I want to establish just a very, very basic check here. We're going to turn the client and the server off for now. What I'm going to be checking is effectively, is my basic premise going to be working at all, right? So what we're going to do here is, let's not comment that out. Let's say in main where we run the client, I'm going to comment this out entirely. And we're just going to establish the basic premise. Can I hash something and use that as a key for cha-cha-20? And then basically we're going to explore the API at the very basic level first with a very testable use case that we can see basically. Because of course, we have no idea right now how to do this thing. So what we want to do is establish that in a very basic context and then use it in the much bigger context, let's say, of using it in this example with the key exchange. Right. So let's see here if we can. We have some bytes, some bytes that we want to hash, which are SHA-256, right? So hash 256. This is the function we actually want to use here. And if we add bytes here, I think hash bytes 256 is what we want. There you go. This takes just some bytes and it produces a digest of the correct size, 32 bits. 256 bits, 32 bytes, if I remember correctly. Let's see what that actually is. We can of course go and look at this, and it is indeed 32 bytes. So that's going to give us that. Let's say digest here, and then we could do random bytes here. I'm going to do that because why not? Math rand is what we want actually. There you go. Rand bytes I don't remember here. Read is probably the one. Read, let's see here, fills a byte slice with random values using the provided random number generator. And this is nil, of course. Basically, it will use the global one if that's the case, and that's not really a problem for us at all. Let's just say bytes here is going to be, sure, 32 bytes. And we're going to say bytes and slice into that. The n here that is basically returned is going to say how many bytes we got, basically. We don't care about that now. We're just exploring this API. And now we're going to pass this to hash bytes. This, of course, takes a slice again, produces that digest here. And then we will use this with, let's see, we have to establish first a cha-cha-20 context, I think, which is a cha-cha-20 context like this. And that context includes a bunch of stuff. It's not stuff that we are, you know, going to be concerned with outwardly or whatever. It's more like we're going to use this. So here they have this init function here. I have actually no idea what size we should be giving for this nonce, if I'm being completely honest. Nonce size is supposed to be something 12 bytes. Okay, so Copilot was clearly correct here, except we need a slice here. What we're going to say is nonce is going to be this, and then we're going to slice into that here like this. And this just takes these as parameters. What we can do here is we can say log debugf. We can log this, let's say digest equals %b. Let's say, let's do the whole context actually. %b. Yeah. Now we should have this cha-cha-20 context. Now the question is, what do we actually do beyond that, right? I'm kind of assuming here that XOR bytes is the thing we want, but that's just a guess at the end of the day, right? So I don't know what keystream bytes is actually. That one is, yeah. We're gonna have to find out some of these things, right? This takes our context of two other parameters, which is the destination and then the source. So we're gonna say we have some plain text. Here we actually, I'm gonna say plain text builder is a bytes buffer. And bytes can't be the name here anymore. Oof, I hate this, to be honest. Random bytes. Let's just say that. And here we want to say plain text build. This is not going to work, of course. We're going to have to say bytes buffer write string, for example, like this. And we take our plain text builder and say, for example, hello world. That doesn't matter so much, right? And here we're going to say that the plain text, plain text is equal to bytes buffer 2 bytes, like this. Yeah, that should be fine. And here we can take our plain text. That's our, no, that's not our destination at all. Encrypted, let's just say that. Encrypted is, well, we can't do bytes length on plain text, that doesn't work. But what we could do is just say 64 bytes. I think that this should actually really be this, right? Because symmetric encryption doesn't generally expand your ciphertext, or plain text rather, right? Your ciphertext is no larger than your plain text, as far as I know. But you know, let's just allocate a little bit more space here, right? Let's do this. Yeah, I think that's a sensible thing to do. I'm gonna put some quotes around this, because if we do encrypt this, we're gonna see some madness in that output for sure. We could of course do basically %x, and we might do this just to get it in hex form, right? But let's do this for now. And now, I mean, let's run this and see what happens, to be honest. Read requires its it requires that n be handled. I mean, I don't know why, because n got %d random bytes. Sure, let's just say that. I don't really give a shit at the moment, but you know. And here, what we can do is just run the client. It's the client that I've modified now, or it should be. We get no output. That's interesting, I suppose. That is definitely interesting. Why? That would imply that we never reach even this point, right? Or do we don't have a logger? That would definitely, yeah. Let's create the console logger here. We actually do this later in that flow. It doesn't matter. This is obviously, we're just experimenting here with this code right now. Okay, we got 32 random bytes, whatever. We have a digest. Plain text is hello world. And then we have encrypted, which is just obviously a bunch of nonsense, right? Now, the question is, if we now do the reverse of this process, right, what is going to happen? If we now say destination is decrypted, the source is encrypted with the same cha-cha-20 context, what happens, right? Because this will basically either verify or, you know, upend the theory, right? The theory is this could potentially work this way. But we don't know until we actually execute the functions and see, you know, what's going on. And we can see we're wrong, right? Or we're wrong about how to call this particular thing, obviously, right? So, what do we want to check in that case, right? Do we need to create a new cha-cha context, for example, for the decryption side of this? This could be the case. Let's try that hypothesis, right? Let's do that down here. Let's say just decryption context, like this, right? This is a cha-cha context, and we'll go through the same thing as everything else, right? Effectively. Did I ever log the nonce, by the way? I didn't. No. So here we have this, and now we would want to. Hello, Max, and hello, Hussein. So decryption context. Let's see what this gives us, right? Because this could also be the case. You have to effectively create a new context to do this, right? With the same key, of course. And we'll see. Okay, so we can see we're getting hello world decrypted, right? The main difference here is that we are obviously logging a bunch of trash in the string, right? Because we're logging the entire string. We're not just logging, we're logging 64 bytes here, right? In the decrypted content. But that is obviously not all of the content that we have in there, right? What it has basically decrypted is, in some sense, a bunch of irrelevant stuff in there, right? So what we can do about that, just to get clearer output, for example, could be, for example, let's say here, let's say plain text content there, and here we're gonna make a constant. I don't usually use these, to be honest, that much, but here I think it might be relevant to do. So what we're gonna do, because this is a constant, we could potentially actually make the arrays sized by that. Let's try that and see. All right, so we have len plain text content instead of 64, for example. Right, and this could potentially actually work in our favor as well. Let's see. Plain text hello world, decrypted hello world, right? So now we know how to use this API, and we tried this, of course, not in a context, a big context, which we had before, where we went through key exchange and so on, right? We tried this in a much smaller context just to verify a hypothesis, right? And we found a hole in that hypothesis, and then we modified our, understanding, and then we reached a place where, yes, we can actually use it this way, right? So the key to our kind of missing knowledge here was, in fact, we need two different SHA-20 contexts, both initialized with this hash value, right? So just to kind of clear this up a little bit, because of course we have just a bunch of a wall here of code, right? We're gonna say here that we're gonna construct some values up here. We're gonna pretend this is C now, okay? So I don't know if people know this, but in older versions of C, you couldn't actually initialize, you couldn't actually declare variables in line. You had to do that at the top of your function. So we're pretending here that we're cosplaying C, right? Here we're first going to get some random bytes, right, into our random bytes slice here. We're going to pair that with our logging. We're then going to create a digest from, right, get random bytes, hash bytes with SHA-256, size of SHA-20 key, right? We're going to initialize for encryption, right? And of course we can, some of these things we can actually just put aside a little bit, right? We can effectively say, no, we don't need that to be down there with the more important stuff, right? So here we're going to be encrypting and this can also be there. Right, this is basically what we have, right? The steps we went through just to figure out what are we supposed to be doing here, right, was effectively these. We got some random bytes, just because we need bytes, right? This is just so we have something to hash, right? Because the hypothesis is we can hash some content with SHA-256, which is the expected key size of, so 32 bytes is the expected key size of SHA-20, right? And we need those keys, right? Then we initialize a SHA-20 context with that hash, right? Because it's appropriately sized and everything, right? And that's what we're doing here, right? We do some logging, of course, but this is beside the point. We then encrypt the context we have in this plain text value, right? This is hello world at the moment. And then we basically say, okay, make an identical context for decryption. Initialize a completely new context, obviously, right? For decryption. And that's the key we were missing. We were then trying to decrypt with the same context, and that does not work. Now we know the limitation of, you know, our previous, let's say, assumption. And now we have something that works. We can decrypt this content and we get something that actually makes sense. Now, the idea is now that we can actually have a step after here that uses this encryption, right? And actually does something with it. I also have one other thing I want to check, just because I'm curious, right? The nonce that we are applying here, I'm wondering which things potentially do they mutate this value? I'm interested, right? I don't know exactly what this thing actually is supposed to do for us here, right? A nonce here, of course, is basically a random value that's supposed to be used and be different for different messages and so on. So what I'm curious is, does the cha-cha init and cha-cha XOR bytes modify this value? Because this, of course, should probably be stored inside of the context. Let's look at the code to see, does that make sense? Here we're calling hcha-cha20 with n. So it's passed here, right? And it's passing basically in blocks, sort of. But it says, yeah, I'm not sure about this. We can see that that would be the place it's modified, because the other places do not necessarily deal with this. Oh yeah, we're not we're not gonna go too deep into that. Let's spare ourselves a little bit of, you know, on-stream pain here. I don't know that this is going to be what we need it to be there. So we're gonna just sort of see if we can find out any interesting stuff by looking at that value here. And then we take the nonce value here. Yeah, let's do that and see what actually kind of happens with these values. Hello, Ivan. How are you? How is everyone actually? Is everyone good? Okay, we can see that the nonce here, it remains unmodified entirely, in fact. So that is a little bit, to be honest, a little bit curious, right? Where was I missing this value? Nonce. Oh, contexts should be here, of course. Cha-cha20 context. Yeah, I don't know why I needed to log this twice. I did not need to log that twice, in fact. Here we can do it though. Hello, Chimekas. A lot of semi-regulars showing up today. That's cool. So our nonce remains as it is. Interesting. In fact, it's never stored in the context at all. I don't know what I was thinking. We can see it's not. Now, of course, that makes me... We could basically always get the random nonce, like I said before, right? We can initialize effectively a random number generator, right? With our shared secret. Yeah, this is also what I hear. This cha-cha20, I mean, it sounds like just a happy exclamation or whatever. Yeah. To be honest, I've heard it in passing before, ChatGPT, or seen it like in the module list and so on, but I've never paid any attention to this, right? But yeah, it's there. So what we could do for this nonce value, if we do want this value, which I'm assuming we do, is effectively, we could generate this from our shared secret, right? So we could seed our number generator, random number generator. Let's see here if we can look at this somewhat. So if we go to rand, we can actually initialize a random number generator here with a seed, right? So that seed could be our shared secret, right? And so for those who might not have been here before, or whatever, and aren't informed, a seed can be used effectively as a starting point or whatever for a random number generator. If you give a given seed to a random number generator, you will get the same random values when you ask for it, right? So I initialize with 5, and then we get some random values. If I initialize with 5 again, we're going to get the same values, right? This makes it useful for reproduction, and it's just how things work in the end, right? That's also why you can play video games where you play on the same seed as someone else, so you can compete on what is ostensibly a random map or whatever, but you have the same random map, right? And so on. So what we could do is we can use our shared secret that we established via, the key exchange to see this value. That is kind of my thinking. And here, you'll see here that if this is a U64, right? If we go here to our trusty IEX, we can see 64 times 8 is 512. Well, there's an algorithm that will give us that many bytes, in fact, as a hash. So I propose we do effectively the same thing we were thinking to do with the other stuff, and we just throw together effectively a, let's see here, SHA hash, that's not the one we want, hash bytes 512. In fact, this is going to give us 64 bytes of a value. Now we have two ways we can use this shared secret we have, right? I think this should be fine, right? Yeah, we're gonna try this at least. I think it will be an interesting thing to explore a little bit here, right? So what we could do again is we could effectively explore this like we did with the other stuff and say, yeah, we can hash actually the same random bytes we had, in fact. Yeah, let's see. Yeah, let's say seed digest is equal to SHA-2 hash bytes 512 random bytes, like this. I mean, here we could actually give it the same thing over and over again, so we can see that, everything makes sense, to be honest. But let's do this first. This is our seed digest. It's going to be 64 bytes. And then we're going to establish this rand context. We, of course, have rand already. Let's see here. Let's create a rand value like this. I think we should. Random, let's say RNG, and here we can have rand init, indeed, give a pointer to RNG, and we give our seed digest here. This, of course, is a U64, but what we can do, we should be able to do, is say transmute this as a U64, and Odin should be like, yeah, that seems fine. This is 64 bytes, right? Let's see. Oh, hang on. Oh, that's a U64. What was I thinking? I was thinking 64 times 8. That's not quite the size we need. That's definitely a lot more. We don't need quite quite that much. So, okay, we're not gonna do that. Actually, there's no hashing we can do that gets it down to this, actually. We could, of course, reduce this. We could just take part of it, to be honest. But that seems pointless as well. Yeah, we only need 8 bytes. I don't know what I was thinking. So we need 8 bytes. But surely there's no hashing algorithm that will get us to just 8 bytes, right? Let's see if I can find this in the notes. Oh, actually, we could try XX hash, actually. I have used the 32 one because it's used actually in LZ4. Let's try that. Crypto hash. Oh no, we don't need this actually. No, hang on. Crypto XX hash? No? Hash XX hash, this one. Right. Okay, so our seed digest will be XX hash, and this should be now this one. And this is now U64. And now we don't need to do any transmuting, in fact. Now, let's do log debug if, actually, let's say just x1 rand which one can we do here? I mean, like, I guess let's just do this one, to be honest, right? And then we pass this pointer to RNG, because now we have our own generator, right? It's just that one. Normally, or well, let's say when we just want some randomness in a program, like we wouldn't pass anything here. We just do the global random, right? But we have seeded our own, right? So what we can do here is do just some random numbers and then just say log debug if, like this. And this, now this will prove nothing, of course, running it once like this. And we will generate random bytes every time, right? Right, so, okay, actually, I have an idea. Let's just log seed as well. By the way, if anyone is wondering, like, hang on, seed digest, U64, right? Yeah, all digests are just numbers of different sizes, right? You're obviously used to seeing hashes and stuff, which is a bunch of letters and numbers, right? But this just the hexadecimal representation of that number, right? So when we have a hash that's 512 bits, we just have a large number. That's it, right? All hashing algorithms just reduce something to some number, right? It is just that we can represent that in many different ways, and usually you want some kind of readable version that says, you know, oh, this is, letters and numbers, right? So we have a seed here. And what I want to do now is just say, okay, Mr. Smarty Pants, what if I literally just give you that number? So we're gonna copy these numbers. I know myself, I'm gonna have a tough time finding this shit otherwise. Yeah, these are our numbers now. We're gonna copy that and just slide that in here. Yeah, that's not, hang on, I've cut something off, right? Because what is happening with some of these values? Wait, okay, let's look at the values that matter. I'm confusing myself. The seed doesn't matter in the second example because we set the seed. So what we can do is we can confirm, yes, when we seed with the same number, we're gonna see the same numbers, right? This is what I was explaining before. The seed makes it so that we can actually, hello Shaiful. Shaiful. You're back. Hello, hello. So anyway, when we seed with the same numbers, we're gonna see the same random numbers be returned, right? That's the hypothesis, which means, let's say two sides possess the same random number together. They can now seed a random number generator with that number, and they will guaranteed be receiving the same random numbers when they ask for new ones. Meaning, if both of them are well aware when they should ask for random numbers and so on, they will be fine. Effectively, they will have the same randomness. And it's a randomness only they can have because no one else has the shared secret. So that's the idea. That's what we're going to be doing basically. Now I'm curious though. Well, no, I think we're going to be fine. We could just XX hash this because we're seeding a random number generator with the hash of some much larger content. I think that will be, I'll have to double check this with someone who knows what they're doing to be completely clear. Right, and then basically I think we'll have to kind of deal with that basically, probably. Because I think, you know, I don't want to make this and just be like, oh, it will sort itself out. Because with security, the problem is when you fuck up, like other people, potentially other people are going to be, you know, in trouble because of you. And that's not what we want. So of course, I'm going to have to establish that using XX hash here, because the note I've made about XX hash here is, of course, yeah, for non-cryptographic use, this is fine. But that's in certain contexts, right? Here, we're taking a shared secret that was established, presumably in a valid way, via Diffie-Hellman key exchange. We're then hashing that down, right? This is not being sent anywhere either, right? This hash, it's simply being used in order to seed a random number generator, right? So, you know, but these are the things you have to think about at the same time, right? So you can't be too careful when it comes to stuff like this. I think it is always better to try to say, you know, okay, I will try to find someone who actually knows this stuff and, you know, consult with them, right? Because you'll have people vetting your code anyway when it comes to security. Okay, so Shaiful, yesterday we had a little bit of like, okay, I don't understand you, you're saying nonsense things and so on. And I feel like we're on that train again today. So I'm just gonna cut that off here. So we don't have to do this dance, you know. So I'm just gonna time you out. And, you know, because Mac Wi-Fi enable and then a MAC address. What are you talking about? You know? Anyway, obviously you can't answer, but I want you to take this time to think about, what am I typing in this window? You know? It's not like you're being offensive or anything. You're not saying anything offensive to anyone. You're just saying nonsense. And to be honest, like we can all just do without that. I'm not desperate enough for chat messages to want just random garbage in the channel. Right? So when you have something that makes sense, like, oh, a comment on, you know, what we're doing, or a question about Odin or something, feel free, right? If it's not that, I think you should probably hold off a little bit on typing things, to be honest. So we should pre-allocate 2 cha-cha-cha 20 contexts. So let's say encryption context and decryption context. I think this might be reasonable. And we could also actually say, yeah, we're gonna have to do this one as well, I suppose. And we have to have some a rand, which would be RNG, like this. We don't need these though. So we have our shared secret here, right? I guess let's hash this in 2 different sizes. Secret digest. SHA-2 hash bytes, yeah. Not the string though. Oh, okay, that's actually a good point. We could hash the string 256. We already have the string, is why. Of course, we could just use the byte stream here. We're only really getting the string because we're printing it. But because we have the string, let's do this now. I think that will be fine. We could also say RNG digest is XX hash XX64. This one. Right, this is a proc group, so we could hash the secret digest, but actually, that's a good point. Yeah, let's go with that actually. Not super... Hang on, why is this looking so strange? XX... I check... Yeah, it's this one, yeah? Yeah, it's this one. Yeah, okay. This takes the secret digest and basically seeds the random number generator. This should all be fine on both sides. And then now we can ask for numbers, basically. Now we have some kind of session random number generator that we've established here, right? Let's attempt to check that again, right? Oh, right. RNG digest is this number now. And then we basically say rand.init RNG with our RNG digest, right? Like this. And here we can say this rand in 31 RNG oppa. let's do the same thing we did before, right? With this one. Now we're going to be doing this on both sides, right? And so let's see here. Okay, we're not using those, so let's just do this for now. And this was all in the client side, right? We're gonna have to do it on the server side as well. Luckily, we have a good marker for this. We're gonna have to make the secret digest and the RNG digest and the RNG, right? So let's make those up here. Secret, no. RNG, rand, right? And really, we don't need more. The other things were actually the cha-cha context and so on. Let's just stop here for a brief break. I need to walk a little bit. I also need to let a cat out. I will be back, not in 5 like it says here. It's 10 from now. Opa. Let's just do this. There you go. All right, I'm back. Let's see here, where did we leave off? We have RNG here. We're printing now on both sides, X1, X2, and X3, which should be seeded from the same thing, hopefully, is what we're thinking, right? So we're gonna run the server here, and then we're gonna run the client here, and I have not modified the client yet to do the right thing. So that's something we have to do. Let's see here. Obviously we don't want to do these things anymore. Actually everything up here we just want to not do. Right. So let's see here. Bytes, crypto, sure. Yet another cat has to be let out. Sorry about that. Hi there. Hi there. Hi there, Elsa. There you go. All right. Let's see here. Let's run the client as well. The server should already be running. Let's see. So on the left side we have X170 like this. Actually we can just do this and paste those here. And yeah, now we have basically a secure way to get the same random numbers on both sides, right? As long as we ask in the correct order, which should allow us to now generate these nonces, right? So if we look up what a nonce is, which by the way, there are other things that are nonces. Don't look those up necessarily, but you know, a nonce is an arbitrary number that can be used just once in a cryptographic communication, right? And so the idea here is that we generate these nonces, right? Every time there's a message that needs to be sent, for example, right? Not 100% sure how we'll coordinate that in any kind of more complex system, but you know. So now we have effectively a way to get the same random numbers, right? So we're going to use that for this nonce business. And so on. Let's see. We're gonna do these ones here. And yeah, I guess here really, yeah, we're gonna have to initialize these after we get this stuff here. Let's remove X1, etc. We don't need those. We only needed to demonstrate that both sides have the same random numbers, right? Which obviously they should, because they have the same shared secret, which was used as the seed and so on and so forth, right? But now what we're gonna say is that the nonce here, no, we're not gonna do that. We're gonna do rand read into the nonce. The nonce is 12 bytes. And once we've done that, let's log the nonce. Sure, not super concerned about that. Let's do a %x there. Now we can initialize the context with that, right? Something like this. This is the client we're editing right now, by the way, I should say. So here it would be interesting, right? Would it be interesting? I mean, what I'm thinking is we effectively make some kind of interface here that either sends a file or something encrypted, right? Or we read from standard in, and encrypt the thing that's being written and send it, right? And then on the other side, of course, we log that here's the encrypted content we received, and when we decrypt that, we get this, right? Because in that case, we could actually say, oh, well, now we're sending encrypted content, right? And so on. Maybe we should do that. And let's say state send messages like this, right? So if you remember from last time, we actually have these state transitions that we go through, right? So we have these client states and server states, right? What we're going to do here is send messages. It's going to be one of these states, and the send messages is going to be specifically for the client. The client is the one sending the messages, right? So now we're going to go down here and say there's no return here anymore. We instead have a case send messages like this. Let's see if I can, yeah, we have a case. Actually, where does this go? Yeah, that's for the switch. And when we do want to send messages, I'll be honest, I've never read from standard in Odin. And that might sound like, what? Are you serious? Yeah, I've never had to. That sounds so weird to say that, because I just feel like I should have somehow can we just read from standard in? No, that's not gonna work. Hang on. I have, which module is this in? So can we just read OS like this? I suppose we can. Yeah, exactly. Like, we don't necessarily, I mean, you never really do that, right? You kind of read from the command line, or you're getting packets from somewhere, or whatever it might be, right? So I literally have never had any point to doing it. And it's so strange, because it's like, well, you would expect to still know it, maybe, right? But no. We're gonna do this now, and we're gonna see if that works, because, you know, whatever. We're gonna read into the send buffer, actually. And then we're gonna just sort of encrypt that bad boy, I think. Yeah, we'll see how we're gonna put this together, you know? Unable to read input seems like a reasonable error to have. Let's actually... I'm gonna just put that there. Ah, this is not a state. This is an error. Let's put that one here. This is actually an erno, if I remember correctly, so we have to be on top of that. Unable to read input there. And here we kind of want to do a for, right? Because we want to do this over and over, to be honest. And declared but not used. Yeah, that's fine. This should be OS error none for those who might be interested. And declared but not used. Rand requires. Oh, this should be the other way around, in fact. Yeah. Yep. There you go. Now we've read some amount of text, right? And now we want to, sure, if n is 0 we can break, it doesn't matter so much to me. It's not encrypt, of course. It's cha-cha-20 XOR bytes with our context, and then our send buffer. Now the question is, hang on, can I use the same buffer in both of these arguments? Because that's actually what I have. Let's try that and see. I'm curious now, you know? We're gonna try it. I'm skeptical about that, to be honest, but you know. We're gonna say just send this on this, of course, and if we have this, unable to send message. I think that's it, to be honest. Let's just go with that. I'm pretty sure something is going to be wrong here, but you know, it is what it is. On the other side of this equation, we want to do some stuff, right? And here we, broadly speaking, want to do the same stuff. So let's go down here and copy some of this. Yeah, we can do this actually. Receive messages. No return, of course. Case receive messages and so on. Let's see here what we can do. Receive messages. No. Receive messages. And here we obviously want to just receive the stuff and receive error, net receive into the receive buffer like this. I think that should be fine. If we have some kind of receive error, just, you know, whatever. If we receive nothing, yeah, honestly kind of not. I mean, that just means client disconnect. It doesn't mean anything to us right now. And here we want to do essentially the same operation here, right? I kind of want to print some of this, of course, on the server side. So we're going to do that also. Before we XOR, we're going to log debugf received this many bytes, and the string of this is going to be receive buffer to n, right? Always right? No, that doesn't. We're gonna decrypt this here, right? And then we're gonna see what happens. Again, there's a big question mark here. Can I actually use the same dest buffer as my source buffer, right? And that's a little bit, you know, let's see here. Put a couple of things on in my snippets. I think I have std in, standard in, or something in there just in case. Yeah, no, it's a reasonable idea, to be honest. I mean, it just sort of is a good thing to have, obviously. Let's see here. We want these up in the server as well. There you go. Redeclaration of secret digest in this scope. Where do we have secret digest actually? Did I put that up here? Okay, I must have copied something twice, I suppose. That's all fine, doesn't matter so much. Now both sides should be somewhat prepared for this, right? Set up, I should say. Prepared, they're not people. They have no concept of this. But okay, let's see what happens, right? We'll see kind of, you know. Oh, I don't have a prompt, by the way. So when I type, it's not like I am told that I can type things. Right, so here we can see we are in fact receiving a bunch of, you know, mumbo jumbo that we then decrypt into what I actually typed. So we have functioning encryption as far as we know. In fact, so that's the general idea, to be honest. Once again, I seem to be making these a little bit, I mean, this is going to sound not very humble, I guess. I keep making these too easy. I guess the goals of every stream, but that's mostly because, I mean, this area, I'll be honest, security has always been one of those things that I sort of have always felt like, okay, this is, you know, it belongs to other people to care about this stuff. I care insofar that, you know, I want security, of course, but, you know, it's libraries, you use people's libraries and so on, because obviously everyone always tells you, you should never roll your own blah, 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 obviously. I now, of course, nowadays recognize that this is basically mumbo jumbo, this kind of stuff of, you know, you should never implement anything and so on. Because the truth is, we're not implementing encryption here. We are simply adding encryption, right? And trying, of course, to follow a reasonable implementation of Diffie-Hellman to do so, and so on. And if I were to do this, you know, in practice and so on, in production, I would, of course, consult effectively experts on this, right? I would try to find experts and ask them exactly to have some kind of audit or something, right? But we never actually get better at anything if we don't practice stuff. And here we are practicing adding encryption, right? And we can actually say the theory behind this is sound, right? We have a shared secret. We are using that shared secret in order to, you know, actually do things, right? So I think we're pretty well set up here. We have in fact added these things. Is Jay here, by the way? Because Jay was wondering yesterday, like, how can we use this shared secret? And this is kind of what today was about, obviously. So I'm wondering if maybe he's here and he can sort of, you know, fill me in here on, you know, does this stuff make sense, what we're doing now? What are we thinking about this, you know, and so on. Because this is what I was kind of thinking yesterday that we would be doing. And now we have explored a little bit of the APIs. We've explored, you know, how can we do this and so on. And I think we have arrived at an answer, right? We can use the shared secret in several different ways. We have now used it in order to initialize two ChaCha20 contexts, one for encryption and one for decryption, and so on. And we can see that we can send multiple messages with encryption, and on the other side it will function much like the actual encryption, and so on, right? So we can here we can say, right, and it all makes perfect sense, and so on. Is there anyone that kind of is wondering, like, hey, what did we do here? Was there anyone that maybe felt like, hey, I didn't really follow, or maybe you weren't here from the beginning, or whatever, and you might want, you know, an explanation of what have we actually done this time, or even last time? Or am I just background noise? In which case, I'm fine with that, of course. That's also fine. I know that the live streams have a little bit of a different kind of, you know, character than, of course, the actual videos where I'm trying to constantly inform someone or whatever, right? Whereas now it's more of a, we're all just kind of here. I'm really happy about this. To be honest, I expected everything to be much more cumbersome and not as straightforward as it has been. And I think it's straightforward without being like, oh, it's straightforward because you're doing it wrong, you know? I don't actually think that's the reason that it feels straightforward. I think we have a reasonable basis to kind of a foundation to stand on with, you know, this shared secret, setting up a, you know, a random number generator, all of these things, right? Now, of course, one thing I will note is that we might want to refresh these contexts with new nonces. We are only reading a nonce once, and then, you know, that's the context, right? So potentially here, what we could want to do, and what I want to kind of see if we should do, is to say here that we say nonce rand read. We read into the nonce again, right? We read into the nonce again. Then we do cha-cha 20 init on our, in this case, decryption context with our secret digest and the new nonce. I'm going to copy this to the other side because this is the server and this is going to be the client down here. And here we're going to read into the nonce from the RNG, and this should do the same. It should get the same bytes, right? So we're going to try that again here. Rand read. Ugh. What a piece of shit. Assert n is higher than 0. That's all we're going to do. Secret digest does not exist here. Okay, that's not what I want. We're gonna actually put that as a quote-unquote global-ish kind of thing. Secret digest is going to be, I guess, this. I don't really remember, if I'm being honest. Redeclaration of n in the scope. Ugh, random bytes. And that's that taken care of. Random bytes is going to be here. Assert random bytes is more than 0. And then we have this undeclared name again, the secret digest. And that is going to be solved by just saying secret digest is here. And we're going to say that that's 32 bytes secret digest, like this. There you go. Now we're noncing over and over. Noncing as a verb might be the wrong word choice there. Let's see. I've been listening while working periodically. We're playing at like 3x. Yeah, that's a good choice, I guess. Hello, Frizzy. Frizzydoo. Frizzydoo. That's a good nickname. Frizzydoo02. What a bouncy nickname. Or, I guess nowadays a nickname is not really what you call it, to be honest. Hello there. How are you? So now we're actually generating new nonces every message, right? New nonces every message. It's the new hotness. And it's still working, right? Because we're on the same RNG, right? We have initialized the RNGs, right? With the same value. Which is good, right? Because we are constantly reading into this nonce value here. And of course, you have to keep this in lockstep with each other, right? The key here is that the decryption context in one is updated as much as the encryption context is in the other. If these were out of lockstep, we would in fact be ending up in a situation where we simply can't read the messages anymore. We're out of sync, so basically the session is now broken, right? And so this is something where I'm assuming that there are smart ideas for how to handle that, right? We are not implementing those smart ideas. We're simply relying on pure imperative logic here to do this. And you could have some kind of message counter sequence, value, where whenever you update the sequence value, you also generate a new nonce, for example, right? And then being on the same sequence value in a protocol would mean, well, then you must have the same nonce. Hello, Rezwan. Can I make the Odin documentation easier and informative? Okay, so I mean, I can try. I should say that I am actually I'm not entirely sure what's going on in that sentence, but I should make it clear. I am not the creator of Odin, just so everyone is fully 100% aware of that. I am not in any way responsible for Odin as a whole. I think it's everyone's responsibility to make the Odin documentation easier and more informative, certainly. And it can be. There are tons and tons of, holes in it, I would say. I haven't made a huge effort to remedy that, to be honest. But yeah, I agree with you that the Odin documentation should be, generally speaking, better. Yeah, absolutely. But yeah. But I think, it's a small community. You can't always kind of expect that stuff should be just good, right? Because think about it like this, right? So actually, I'll point to a talk again that I pointed to in a previous video. The Economics of Programming Languages by Evan Czaplicki. So this video, this is the one. I'm going to paste it in the chat here. I think that this video makes a great argument for we simply cannot expect all languages to offer the same things, right? As an example, right? Some languages are, of course, they were spearheaded by companies that have upwards of $3 billion in revenue, right? So consider for the moment what that means. They could allocate less than 1%, right, to making the Golang documentation good, right? That will be more money than Odin has for all of Odin, right? So there's a great argument to be made for you simply cannot expect, right, languages that have no sponsorships, no corporate donors, no company that is responsible for the language and so on. You can't expect these languages necessarily to have the same things as everything else, right? Odin is a very good language. I think new learners can easily use it. I am CTO of a company. I was wishing to use Odin in our system level stuff, but we can't now due to lack of doc support. Well, you can improve the docs. I mean, this is not someone else's responsibility. I'm sorry, but that's the reality of the situation. And I don't think you should use a language that you can't use without docs. Actually, I think you shouldn't use any language that you couldn't use without the documentation, to be honest. So for example, if someone removed the documentation for Erlang, right, I can still use it. I know most of Erlang inside and out, right? So that wouldn't be a problem really. But I don't think you should use a language where you don't feel confident enough to use it without, you know, the docs, to be honest. And I don't think realistically that you were ever going to use Odin if the docs are your blocker. Right? If someone has told you you can't because of the docs, it's more likely they're kind of lying to you, right? Because it's either going to be a good language for your use case and you would use it, or it's not, right? Or it's a general lack of maturity, for example, in which case you should probably just go with C or C++, right? The docs, I'm sorry, but I don't really believe that that's the case, right? As a low-level language learner, I mean, that is kind of the point where Odin is at the moment, Frizzy, right? So the way I view Odin is for, let's say, enthusiasts at the moment, right? It is used in production, to be clear, right? And I mean, my very first Odin video on this channel shows that, right? It's used in a professional product for special effects, an industry with lots and lots of pressure, right? And it's used for a use case that requires you to actually deliver something real, right? You can always be better at generating fluid simulations. You can always make it faster. You can always make it better, more realistic, more everything, right? You can always use more computer power and so on, right? And it is used for that. So, you know, but I think it's for basically, let's say, enthusiasts. I'll give you some context. Historically speaking, I have been 5 or 6 years ahead of the curve on languages. Back in, let's say, 2017, I was into Rust. Right? Rust did not become particularly big until years later, right? So I would say it's possible that you are finding yourself ahead of the curve suddenly, which you are not used to. And now you're expecting things to be much later in the curve, right? I'll illustrate this with a diagram. There's a well-known diagram here that people tend to use. So, Rezwan, what you're kind of looking at is you are used to being here, right, on this side of the curve. So you might have been using Java in 2008, right, for example, or something. Or you thought Go was too new a few years ago, or something like this, right? Late majority and laggards, right? This is a very large group of people, right? The people who are adopting Rust right now might be in the early minority, right? And they might usually not be that. They might be late majority usually, for example. But you're here. You're early adopter or innovator here, right? Now, that's where you find yourself with regards to Odin. And I don't think you understand that necessarily, right? I don't think you've considered that maybe you're seeing Odin in a stage that you're not used to seeing languages in. Because Golang, like for context, right? Golang is 14 years old, right? And I think that might be what, 1.0? I don't know. But in any case, it's 14 years old, right? That's a few more years, right? But people who are adopting Golang now might be a late majority, I don't know. And then the people who are like, oh, well, you know, give it 10 more years. I guess these are the laggards or something, right? But yeah, so you should be aware of where you are on this curve, right? I find myself usually being an early adopter, right? I started using Elixir back in 2015. And basically no one had heard about Elixir in 2015, right? But I'm also well aware of when am I adopting things, right? So in 2019, I started using Zig. Zig is now getting kinda famous, right? And now the early adopters of Zig are showing up, right? They're not even early majority. They're way earlier than the early majority, right? So, you know, as a consequence of knowing where I am on this curve, I don't expect things to be done already, right? Odin will probably not have a bootstrapped compiler. That is a non-goal of the project. It is not a goal to have an Odin compiler in Odin, as far as I know. And there's much, much more interesting and important work to do before any of that happens as well. The C++ compiler is fine. But yes, what do you mean suitable? It's already used in production for what I can only assume is a multi-$100,000 project. Probably more than that. I have no idea, you know, how much money JangaFX makes off of Embergen, but you know, I probably shouldn't even speculate, to be honest. But my point with all of this is, don't expect everything to be done already, right? It's just not going to happen. You are finding yourself in a land where people haven't moved in yet, right? We're talking early frontiers. So, you know, Wild West or whatever you want to call it. But yeah, I don't think that the goal is to bootstrap Odin, to be honest. And that's not the goal. That shouldn't be the goal for any programming language, really. That doesn't mean that it's ready. It means the language is good for writing a compiler, to be clear. So that's not a thing, right? I mean, in fact, Odin could be production ready for 15 years and still not have an Odin compiler. I don't think it would matter at all, because writing compilers is not the goal of languages, right? So I guess Odin would definitively be ready for production when, I don't know, when there's like 100 production things written in Odin. I don't know what limit you want to put on this, but we know that there's one, you know, bet by one company, and I don't know, I guess that's it, really. I think you will have to, you know, to be honest, I think you would have to gauge this yourself a little bit, right? Because the questions you're asking, I'll be honest, don't really make sense for like, is it ready? That much. And if you are a CTO, I would really just expect you to, well, look at what Odin does have, what it doesn't have, and analyze it not from like, oh, is Odin ready? Say instead, am I ready to use Odin? Right? Because, so let me put some context on that, right? This is going to come down to a few things, right? You will have to write the majority of the code probably, right? So what are you trying to do? If your product, if it uses networking, if it uses graphics APIs, and let's say that's the extent of it, Odin is very well set up for you to work on this. Absolutely. If you want to deploy on Windows and Linux, the Windows part, I'm not sure about sockets on Windows. Not really sure. Haven't really tried it that much. So I can't give you any estimation on that, right? Linux, yeah, it should be fine, to be honest. We don't have ePOL. You could add ePOL. Not super concerned about that, right, to be honest. It depends what kind of server infrastructure you would want, to be honest. If you're writing some simple clients with basic server needs and so on, and you don't expect that many clients to be connected to the server or something like this, Odin is super ready for you. It has been for a while, you know. If you're doing graphics in Odin, 100% it's readier than any other language that I know, to be honest, by basically just default. That's because the vendor libraries are already there. You have bindings for DirectX, Metal, OpenGL, Vulkan is in there now. I'm not entirely sure about the Vulkan bindings, but I'll see soon because I'm gonna start using them, and so on, right? If those are the things you're doing, Odin is ready. Yeah, I'm pretty sure it's ready. The code though that you're gonna have to, that's gonna run your program, you're gonna have to write it yourself, to be honest, right? It's not like Odin has some massive ecosystem that you can rely on. And for some people that means it's having a massive ecosystem means it's ready. For me, that's not a thing. It doesn't really factor in, to be honest, right? So I would say, don't ask if Odin is ready. Ask, are you ready to use Odin? Because that's really what it comes down to. Someone could start writing an operating system in Odin tomorrow, and they could finish. Does that mean it's ready? I don't know. People have made games in Odin. This is not a thing where there's a virtual machine or things like this. It's basically just we're writing a slightly better C, That's it. So yeah, I would say it really depends on you. And then it depends on the human factors, right? The actual, let's say, quote unquote, soft side of this. Is everyone else in your company ready to use Odin, to read Odin? Do they understand lower level programming at all? In which case they wouldn't be ready for anything else like C++ either, right? For example, right? So yeah. But yeah, it's about you in the end, right? Does that make sense? Because yeah, I mean, this is kind of what I'm trying to say, that you are the primary decider of, am I ready to sit down and write this stuff in Odin? I mean, there's an HTTP server written by a community member. I wrote an HTTP server in my streams and so on. Can you write an HTTP server? That's kind of what I would probably ask you in that case. But this is kind of a little bit what I mean as well, right? You're going to be responsible for writing a lot of code. But I'll be honest, it sounds like maybe Golang is a little bit more your speed. I don't think you're ready to use a language back here. Like as a CTO, you do not seem to perhaps be at the level you would need to be at in order to join here, let's say, right? While there certainly are CTOs that could. And that's not a slight on you, it's just that, you know, it could be the business you're in is also not really appropriate for doing this, right? But writing an HTTP server is really not difficult, really. It requires time, for sure, and so on, but yeah. But I think Golang would be maybe a little bit more appropriate here, probably for you, right? It's ready. I mean, that's already done. You have an HTTP server in the standard library, etc., or HTTP interface. There is actually a server as well, actually, yeah. Which already has all the bells and whistles, to be honest, right? So it's kind of set up for you to use already. I think, given that you're probably not set up to do this generally, I would just recommend going with Golang, to be honest. Or something else. I mean, there's tons of stuff out there. I mean, for certain contexts, I would definitely prefer Elixir over Golang for web network services in general, but it kind of depends, you know. Elixir obviously is also a little bit, quote unquote, like early still. It's certainly less mature than Golang, I would say. But yeah, I don't know, does that make sense? Because given these questions, right, given these considerations, I don't know that Odin is really the thing you want, probably. Yeah. It's probably just the case that you can't really bet your company stuff on it right now. But keep track of it, I guess, you know? Like, the things I want to make, Odin is already fairly well set up for, to be honest, right? So I feel like I would be in a good place to do that, right? With that said, I always have the fallback of writing network services in Erlang and Elixir, right? So if I ever stumbled upon something where I'm writing a server in Odin and maybe this just does not feel appropriate, I would simply just implement it in Erlang and it would be fine. It would probably even perform better if we had enough clients, for example, right? So that's kind of my own strategy, let's say. And I think if you just sort of leave Odin, you know, in your peripheral vision, right? You have it there, you keep track of it. And then eventually you might find, for example, hey, I have a small project in our company that needs, for example, some performance, but the problem is fairly simple. So for example, we had, I think it was Max. Was it you, Max? You had the image resizer, image manipulation service, let's call it, right? I might be forgetting who it was. I think it was Max. They had an image resizing service or image manipulation service that the idea was to implement this in Odin. And this is a good restricted context, right? It means that you can set this up, you can experiment a little bit, you can explore a little bit, hey, does this actually work? And if you already have an image manipulation service up, for example, you can simply continue using that, right? And then one strategy to do this would be to have a load balancer that forwards request to one or the other, right? In the start, of course, it only forwards requests to the original service. And then you could, for example, say, oh, what happens when we forward every third request to the new service, right? Now you can start looking at, okay, do the response time, do they get lower? Are the results, shit, for example, in practice, like in production, does it matter, and so on, right? There are all kinds of things you can do here, right? So there you have a very clear version of this. You could also have a setup where, for example, you say, and this is of course like depends on the service, but you have a load balancer, right? And basically it duplicates requests, but it always, the actual service that you had before is the one that actually gives the authoritative answer. But you're monitoring that you're getting the same results from both, right? So you're setting up a service that is effectively it's a dummy service. It does work, but that work is only used in to compare with the service that gives the authoritative answer, right? So you'll have your old service, right? And you have your new service. First of all, you can see now, okay, you can measure them to see which one is actually doing it faster. It might be that your Odin code simply is running slower, right? And then you would start working on that to see like, hey, can we get that down? But also, is it actually computing the right results? For example, right? That would be a strategy that you could use. Because it's not like you have to bet everything on Odin, right? You can implement just a part of your system, for example. This could also work, for example, if you have a language that allows you to write external functions, right? So you could, for example, say, I have a function that I'm actually going to be writing in Odin that I then import in this language, right? So I have a video about doing this in Erlang, right? And in Erlang, we can just say, hey, there exists a function that has these, we're going to pass an argument from the Erlang virtual machine, and then we're going to do some stuff and we're going to get results back, right? This is also a version. You can say, hey, I'm going to implement this particular part in Odin because it might be faster, for example. And again, you can now compare this to a slow version, in that original language. Thank you, Asaz. But yeah, there are many strategies you can employ here, right? Adopting a language is not necessarily about switching everything over or basing an entire project on it, right? In reality, there are certainly parts of a project that I would implement, for example, in Erlang, right? Or Elixir, more likely, right? So, and if, I am obviously very interested in using Odin, but at the same time, there are certain parts of a project that can certainly be done in Elixir very easily and very well, right? So from that perspective, like you have to, that's just being, a little bit more pragmatic about it, right? So again, we kind of come around to, it relies on kind of you setting this up, right? This context that you're working in, adopt Odin maybe a little bit, for example. And then, yeah. But yeah, I don't know if any of that makes sense, to be honest. Sometimes when I talk, it's like, am I just in a bubble, does this make sense to anyone else? Because yeah, again, I usually find myself being like 5 years ahead of the curve on a lot of stuff. My view on things is not necessarily representative, right? But yeah, I'm very interested, by the way, in the chatter that did have this image manipulation service, right? Because it's the kind of project that can go well or it can go very badly, right? And it also, usually what happens is that you get confronted with all of the things that might be missing, for example, because this is reality, right? You'll discover annoying things like, oh, for example, in Odin, there's no good way to start an external program, right? And so just to give people a little bit of context on this, I don't know if you've looked into these modules, but we'll do it now. So let's see here. Core OS is the one we want. And so you'll see here in the OS modules, right? If we go to the general OS interface, there's actually no way to run a process. And you'll have to take my word for it, but there's basically no good way to run a process. It just doesn't really exist. However, if we go to there should be OS2 modules. Yeah, there you go. OS2. In the OS2, what we find is process.odin. And we find here that there is a concept of processes, where we can start, we can control them, they have pipes, and so on and so forth. But all of this is unfinished. It is currently in a PR, as far as I know, being, I guess, developed, but it's just not there. Yeah, we don't have a way to start processes and release them and kill them, whatever it might be. We can't send signals to them yet. You can see these are all stubs, right? And this means it is prohibitively annoying to start sub-processes from Odin at the moment. And you would have to do it in a little bit with some tricks. These tricks can, for example, some of them only work on Unix systems, I think. Now, actually, I'm not sure about that, so take that with a grain of salt. But you have to, for example, set up an environment, and then you have to fork. And then, you know, it's a lot more like using certain C interfaces and so on. And it comes with a lot of, like, you have to actually implement some of this yourself, right? These are exactly the kind of things that you'll be confronted with when you actually try to do something in practice, right? So finding a very small context to do this in, right? To find just maybe one of these things, that's what you want to do, right? Because you don't want to suddenly find yourself being like, oh, hang on. So we're missing 5 of the networking functions that we want. We're missing the ability to run sub-processes correctly or, you know, reasonably. We're missing 3 other things, right? You want to take just a slice and say, here's the slice I want to do in Odin, right? This is also why FFI is such a good idea, right? Because with foreign function interfaces, right? So let's go to one of those, code Elixir NIF Sandbox, or is it Odin NIF Sandbox? I don't remember. Ah, it's not this one. It's this one, I think. October 5th. Yeah, this sounds vaguely correct. Let's see here. So this is some Elixir code. Here I'm reading an Odin produced object file, right? We have compiled it with Odin and we're reading it here, right? It has these actual functions and so on. If I go to Odin, let's see here, nifs Odin. Here is Odin code that produces the correct Erlang functions in order to export them to Elixir, right? Elixir is just Erlang underneath, of course. So I can use this to write Odin code that basically calculates results and blah, 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 and gives them to Erlang essentially, right? The beauty of doing this in the end, let's see if we can actually run this stuff. So if I run, for example, hello binary here, I think I can give it a number. Yeah, it will produce 42 O's and give that as a string. The beauty of doing this type of thing, not this in particular necessarily, is that here this is an incredibly small context, right? So you might, for example, say, okay, we need a highly performant map implementation, or we need to do something that there actually is code for in Odin. And we need to do it, you know, reasonably fast, and so on. And we don't care that this is not functional, for example, right? A functional language or whatever. Erlang is functional. So when you implement something in Erlang, there's a risk that you're maybe doing a bit too much copying, it's allocating memory everywhere, and so on. Some of these things you can't actually escape by using Odin necessarily. Some of them you can, right? So from that perspective, right, you can then implement, you know, a small thing in Odin and actually use it in Erlang, right? Or it could be Haskell. Haskell also has an FFI, right, foreign function interface. So, or let's take something a little bit more pragmatic. C#, FFI. Let's just look for this. I've literally never done it. Whatever. Let's see here. Native interoperability. I'm sure that more people, more of you guys, have used C# anyway. So I don't know why I'm talking about Haskell and Erlang. You know, that's not what people are using. So let's see what we can do. Can't they just give me an example? P-invoke. I think I've seen this before. Here we have a DLL import, right? So you can produce a shared library. Just put your library name here, right? Charset, Unicode, I don't know, whatever, man. This is of course using UC32. That's why they're just using this as an example, presumably. But then you can basically just say, oh, this is that you know, that symbol, right? Here we could just have an Odin function, right? It's an extern, and we can, for example, return an int or whatever it might be, right? And so you could use Odin in your C# effectively, right? And it's as easy really as producing this DLL. And I'm sure it can use static objects as well, right? It doesn't need to be a shared, a dynamic library, right? Because that would be silly, right? I mean, I might be eating those words, but because I'm just kind of thinking that clearly it's not like they have to have DLLs, right? Does anyone know? I mean, I've never used C# except, you know, I wrote some kind of oh yeah, I wrote a thing that interfaced with OneDrive once, and actually gave me information about OneDrive. It was I wrote like an example program because I wanted to see what I could do with this, and it was a UWP app, Universal Windows UWP. What's the P for? Anyway, it was a thing. Native library loading. Let's see. DLL import. You know, it doesn't have to be a DLL, surely. Right? Am I crazy? Library import. Oh, but they're still using a DLL. So hang on, let's just Google this. To be honest, C#, FFI without DLL import. FFI static library. Oh. You have to use a DLL. Fair enough. Okay, I stand corrected. I definitely, I did not expect that, but okay. But why though? I mean, this was in 2009. Let's, let's keep that in perspective. Okay. Again, I probably am corrected. This question is from 2015. Microsoft DN is responding to this. It's non-trivial, they say. Okay, fair enough. Hello, Scheifel. Again, what does this what mean? I don't understand. Anyway, so let's step back from this C# stuff. But my point is, you can use Odin in a very restricted context by, for example, producing one of these DLLs, right? And basically using them in your C# code base, right? This is entirely doable, and it's a good idea, right? You restrict the usage of Odin to one specific part, and if nothing else, you can also basically say, okay, maybe this didn't work for some reason. And you can just step back from that and say, okay, for this part of this, we could not use Odin, for example, right? I'll be honest, like for C#, for example, there's definitely a C# way you could get a lot of the benefits of Odin. Well, okay, speed-wise, a lot of the benefits of Odin. The problem is mostly you don't really have a great way to control allocations and so on. It's certainly simpler to write certain faster code in Odin. But for C#, for example, if you're trying to introduce Odin, I think it would be more, it might be, yeah, again, it's simpler to write it in Odin. So you have to be a little bit confident in your maybe ability there, right? Because you probably already have great C# programmers that could, for example, use a lot of the facilities in C# to write, more stack-based code, right? For example. What I mean by that is that a lot of the problems with C# and speed is simply that a lot of stuff is on the heap, right? Meaning it's dynamically allocated and so on, and the garbage collector is putting its nose where it doesn't belong and all of these things, right? So for that, you could basically end up paying a little bit for certain things and so on, and you don't really want that. So yeah, it would be easier in some cases to write that faster code in Odin, for example, because you would have more control over certain things. But C# has certain facilities that allow you to stack allocate. For example, you can use structs and so on. If I say struct here, we're going to find anything. Yeah, records, maybe. No. Stack. I think it's maybe in advanced net programming, maybe. I don't know. I seem to remember that there were a few memory management. That's not really what we want. Oof. Oh, wow. Okay. .NET. Let's say struct. Because I think they made struct basically mean a stack allocated. stack allocated class-like thing, but it's just values. Right? It's value-based, it's not reference-based. And so on. Oof. Where have we ended up now? I think, here's where we want to be actually, I think. Performance engineering is where they put some of this stuff, I think. Right, so you have these guides to reduce allocations and so on, right? And some of these are going to be about using certain instruct types and so on, right? They also have this span, right? Which is basically just a pointer into something, and so on. And with this span, you it's a little bit more, well, yeah, pointer-like, right? There isn't the same amount of safety as you might have otherwise, I think. But yeah, anyway, I don't know how we ended up here. Obviously, FFI, right? Implement a very small part of your system in Odin to see, oh, can we deal with this in Odin? Is this a reasonable thing? And so on and so forth. That's why we ended up here, obviously. I think that's a good idea. It also will allow people to kind of say, you know, what is this Odin stuff? You know, I know we use it in the image manipulation service, or I know we use it for this FFI stuff over here, right? And they can then go and just say, okay, here's this very small slice of Odin. What is this about? Like, can I read it? If I wanted to add something to it, or if I wanted to add a new FFI function in Odin, what would I have to do, for example, right? And so on. So there's a lot of good stuff you can do with cutting off a very small slice of your overall system, right? Either a service or just a function in, you know, in your system. I think we might just say, you know, we're done here, I think. So to recap what we did today, let me remove this import as well. To recap what we did today was we established basically, here's the end result. We are writing things in the client over here. We're receiving them in the server. In fact, we are receiving them encrypted. You can see here each message here, basically when we receive it, we are getting it encrypted, and then we're decrypting it. How this actually works, let's show the client here. How this works is that we have the shared secret value that we established last stream, right? And this shared secret value, no one else can have this. It is completely secret between the client and the server. Both of them get the same shared secret. We established that, you know, last time even. We then actually hash this value, right, to 256 bits. We initialize a random number generator with this. This will allow us to get the same random sequences on both the server side and the client side. We have now effectively established a shared randomness between the two, right? And then we are using that randomness to generate these nonces. A nonce is basically just a value that, a random value that we add to encryption in order for there to be a sequence of random values, so that yes, the key remains the same, but the nonce changes. This effectively makes it impossible for someone to replay a certain packet that's sent, because remember, people can see that there are packets and they can grab the encrypted information, right? And if they can do that, they can then insert another packet that looks exactly the same. So if we didn't have any randomness, right, that made the content look different or whatever, that would be bad. That would open up the door for replay attacks. So for example, an attacker knows that you're sending a message that deducts a certain amount from some resource, for example, a bank account or something. If they knew that because of timing or something like this, they could basically replay that packet 5 times. But of course, we have a sequence of random values that change every message. So that wouldn't work with nonces being part of the question, right? So we generate a nonce every time we actually send the message and so on. Here we initialize an encryption context and a decryption context. We are in the client here, so we're encrypting stuff for the most part. And here you can see, yes, when we do send messages, we read from standard in, we generate a new nonce value, and then we encrypt, and then we send that over TCP to our server, right? And then we just loop again. So we read again, and on the server side, how this looks is we're gonna initialize everything. We have our RNG, it's the same as the other one and so on, right? Here, of course, we receive from the network. We update our nonce value, and this has to be done in lockstep with the client, basically, right? We have to have the same nonces, and we can because we have the same RNG, right? We have the same random number generator. It's seeded with the same value. And here we decrypt, right? We're using our decryption context on the server side. We say how much we received and we log it so that we can see, oh, this is decrypted or this is encrypted, and then we decrypt, and then we output what we decrypted, right? The end result is on the right side, I can type and we see it on the left. And obviously this is running all on my computer, but it is actual networked applications. It's just running on localhost, obviously. And you can see here, the data when it's being sent is of course a bunch of nonsense, and then it gets decrypted into what it should. So that's what we've done today. And then of course we ended up talking about, using Odin and blah, 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 and so on. But yeah, that's where we are effectively. The next steps for this probably would be, implementing maybe some other protocol. I think we're probably going to look into a little bit of public-private key cryptography. Probably trying to see, how would we use RSA, for example, from Odin, right? Because this is obviously, this is one of the schemes you can use with TLS, which we're going to be implementing and so on. TLS is transport layer security. And that's what we use for security on the web nowadays. And this is of course because I have built a web server. We have a HTTP client as well, and we want to have TLS on both of those sides. So we're going to be implementing the TLS handshake, how to actually get a secure socket, and so on and so forth, right? So we're building that. And we need a few of these pieces. We also need to handle certificates, security certificates. These are X509, so X509 certificates, right? We need to handle those. There's a little bit of code to do this in the vendor section of the standard library. It looks a little bit funky, but we'll see what we have to do there, right? If nothing else, we can just read the file ourselves. It's not really an issue. Apart from this, we have a whole set of algorithms we have to look into how to use them from Odin and so on. We may or may not have to use some C code, but I don't think so. There is a vendor library for a lot of different cryptographic stuff. So we're probably going to be using that. The interface looks like ass, but we'll see kind of what happens. We're going to do the same thing we did today. We're going to explore those APIs and see, what do I actually have to do in order to do some of these things and so on. So yeah, next steps again would be probably implement a few more different cryptographic things. Again, we probably would do, I think RSA would be a good next target, to be honest, right? And that would mean setting up some RSA certificates, right? Public-private keys, and basically saying, let's simulate effectively a client connecting to a server and sending, for example, trying out some signing. So signing is the process of you encode something, a a server, for example, would encode something in it with its own private key, and then someone who has the public key can basically say, oh, I will take a look at the signature, and the only person that can actually sign this correctly with the correct hash is the one with the private key. And that's a way to establish that the other side actually does possess the private key that we are requiring, right? This is authentication. It means the other side is who they say they are, right? Otherwise, you cannot know that the other side is who they say they are, and so on. So I think RSA would be a good step here. We also have a little bit of, we could potentially take a look at the math behind RSA, because it's actually reasonably trivial to actually set up an example of this. It's really about the primes involved. So I think the key size for RSA is insane. I don't know, I don't remember what the key size is supposed to be, but it's something like, it's insane, right? So we might have to take a look at, okay, what can we do there? But regardless, actually, I think we can implement this whole thing. We don't really need to use a vendor library for this, to be honest. I think we should. Yeah, we're going to take a look at actually, trying out RSA. Let's build it ourselves and so on. And we're gonna see where we can go with that, right? And that will be probably what we're going to be doing next time. So next time might be tomorrow, or it's Wednesday. We'll see. You'll see your notifications when this is happening. I'm not entirely sure. I actually, for those who are here, you're going to get an exclusive. I am trying to start an interview series with people who do interesting things. Some of them are Odin people. Some of them, so I'm currently looking into, there's a guy called Victor Lövgren, who is creating a search engine by himself. It's called Marginalia. Marginalia is what I would say in Swedish, but marginalia.nu. So it's spelled like this. Like this. He's creating a search engine. It's not your typical search engine. But it's architected in interesting ways. And I'm currently setting up an interview with him because I want to interview him about how one would create a search engine, right? I think that's an interesting prospect. I think a lot of people need probably to hear that creating a search engine is maybe not as complicated as they might think. You could effectively create your own Google. And I think that's a very interesting prospect, right? So I'm currently trying to set up an interview with him. Preliminary plans are that this week, at some point, we will be discussing some of this. And I have also discussed potentially doing something similar with an Odin community member called Zelinsky. Yeah, so that's also an idea. He makes games and so on. So I want to discuss, things with him about Odin and making games in Odin and stuff like this. I would like also to basically do something similar with a guy called, sorry if I want to say his name correctly. Let's see here. Ed Harmush. I'm not entirely sure which one it is. So about security, about a lot of these things. He's an expert at networking, network security, and so on. So I'm hopefully at some point I might be able to set up some kind of interview with him about security and possibly a walkthrough of one of the interesting things in security, for example, right? He has a great video he did with a guy called, oh my God, hang on. Practical. So I'm gonna link his website. So he did a video with a guy called David Bombal, I don't know, about the TLS handshake. So it's a deep dive into the TLS handshake and so on. This is actually where I found this guy, and I would love to talk to him about, you know, security and, you know, the ins and outs of a lot of these things, right? He has a very good way of explaining a lot of these things, and so I want to, you know, actually have him show up, and this would be very interesting, right? So yeah, those are the future plans of the channel. I'm trying to establish this interview series. It doesn't mean that it's going to happen necessarily. We have yet to do our first, right? But I am hoping that this will go well, and we'll see. The first one that's probably going to happen will be Victor Lövgren with Marginalia. And then we'll see about everything else, to be honest. But yeah, that's it for today. And thank you for coming. Thank you for being in the chat. Thank you for participating, or thank you for watching. And I hope that you have a nice day.